So good morning, welcome to Sakal Vidya YouTube channel. So now we have been discussing partial fractions for Diploma Basic Engineering Mathematics. Okay, semester 1. So now in the first problem we have discussed two problems. Now third problem we are going to discuss. So the most of the questions will be previous questions itself only. This will be very useful for coming your examinations also. Right, it may be useful for your EAMCET examination, for competitive entrance examination also. Okay, let us move to the now third problem. Yes, third problem. This is third problem. One upon x minus 1 times x minus 2. Resolve into partial fractions. This is the question. Resolve into partial fractions. Okay, Shanmukha Sai, welcome. Krishnaveni, Sardar Syed. Sir, what about M2? Okay. So create Zoom meeting, sir, for doubt clarification. Okay, that can be done later. Right. So let us start now. So let us recall the previous method once again. Solution. So now consider 1 upon x minus 1 plus 1 upon x minus 2 equals to, this is type 1, so that we get one partial fraction of the form a upon x minus 1. For x minus 2, corresponding to x minus 2, we get b upon x minus 2. We need to find out a comma b values. Kishore, welcome Nana Kishore. So that implies here we have x minus 1 multiplied by x minus 2. X minus 1 into x minus 2 divided by x minus 1 cancel. We have x minus 2 plus x minus 1 equals to, here again x minus 1 into x minus 2. So we get a times x minus 2, am I correct? Plus b times of x minus 1. But in general actually the denominator will be gets cancelled. So these two values, x minus 1 into x minus 2, x minus 1 into x minus 2. So this is part 3. So that implies actually we get, this can be written like this also, a times x minus 2 plus b times x minus 1 equals to x plus x 2x minus 3. So now we need to find out a value. So we need to find out a value means actually here we need to suppress this factor x minus 1. Suppress means equate x minus 1 equals to 0. That means we get x is equal to 1. So that means put x is equal to 1. So we get now a times 1 minus 2 plus b times 0 2 times 1 minus 3. So we get like this. Now a times minus 1 plus 0 equals to, now what do we have here, 2 times into 1 2 minus 3, 2 minus 3. So we get minus a plus 0 minus a, this is minus 1. Minus both sides cancel, we have a equals to 1. Yes, a value have been determined. Thank you, wish you the same all of you. Wish you happy new year to all. Right, next what shall we do now here? So here we need to suppress this time x minus 2 factor. So that means now x minus 2 is equated to 0. So we get x equals to 2. Now put x is equal to 2. So if you put x is equal to 2, just go back to the previous page. So a times this will be 0, a times x minus 2 is 0, plus b times, see, you check here now in the previous page, 2 minus 1 equals to 2 times 2 and minus 3. So 0 plus b times 1 equal to 4 minus 3. B equals to 1. So therefore, so partial fractions are, we have 1 upon x minus 1 times x minus 2 equals to, a stands for how much? 1, a upon x minus 1 plus b upon x minus 2. So equals to 1 upon x minus 1 plus 1 upon x minus 2. So this is the way we need to find out the partial fractions. Yes, it is useful for CSE also. CSE also. Okay, now let us move to the fourth question. Question number 4. That is 1 upon x times x plus 3. So this question is given actually March 2017 question. So it may be in different branches as you asked CSE like that. Okay, let us solve it. Solution. Consider 1 upon x times x plus 3 equals to, for x, let us write a upon x plus, for x plus 3, let us write b upon x plus 3. So we need to find out both a and b values. Am I correct now? So 1 upon x times x plus 3 x plus 3. So here x times of x plus 3 x times of x plus 3. So x gets cancelled, a times x plus 3 plus x plus 3 cancel, bx. So comparing on both sides, what happens now? Here this x into x plus 3 cancel. We have, on comparing on both sides, we get a times x plus 3 plus b times x equals to 1. So as to get the a value, x need to be suppressed. So how could you suppress it? So unless it is equated to, x is equated to 0. So that means now let us substitute, put x is equal to 0. Put x is equal to 0. So what do you get now? A times 0 plus 3 equal to b times 0, so equals to 1. That implies we get 3a plus 0 3a equals to 1. Therefore a equals to 1 upon 3. This is the a value. Now this time, in order to get b, this coefficient b, so we need to equate this x plus 3 equal to 0. We need to suppress this factor now. So now x plus 3 is equated to 0. So what do you get? Yes, you are correct. You get x is equal to minus 3. So now put x is equal to minus 3. So that implies, what do you get now? Here you see a times 0 plus b times minus 3 equals to 1. 0 minus 3b equals to 1. So we have minus 3b equals to 1. So therefore b equals to 1 upon minus 3, that is minus 1 by 3. So we know the a value and b value. So what is the a value now? Here see, a value equals to 1 upon 3. Okay. So b value equal to minus 1 upon 3. So therefore see 1 upon x times x plus 3 equals to, as we have a upon x plus b upon x plus 3. So let us substitute the values. A is 1 upon 3 upon x plus b is minus 1 upon 3 upon x plus 3. So this can be rewritten as 1 upon 3x plus into minus minus 1 upon 3 times x plus 3. So these are the partial fractions, required partial fractions. Okay. Binomial theorem. I have completed a binomial theorem. You can go through the binomial theorem. Okay, Pallavi Macharla, welcome. Semester 3. Okay, I will start. Right. Second question, I think somewhat mistake we did it now. Right. Now, let us do this question is wrong now. We did. Once again, let us do it. Third question. Okay, solution. Consider 1 upon x minus 1 times x minus 2 equals to a upon x minus 1 plus b upon x minus 2. So we need to find out a comma b values. So 1 upon x minus 1 times x minus 2 equals to, here LCM is we have x minus 1 times x minus 2. So x minus 1 into x minus 2 divided by x minus 1, we get a times x minus 2 plus x minus 2 cancel, we get b times x minus 1. So both sides and comparison, this x minus 1 into x minus 2, x minus 1 into x minus 2 will be gets cancelled. Okay. Kishore. So now that implies, what do you get now on comparison? A times x minus 2 plus b times x minus 1 equals to, we have 1. Now we need to suppress this factor. So that means x minus 1 equals to 0. That means x is equal to 1. Am I correct now? Right. In description, right. So now put x is equal to 1. If you put x is equal to 1, this becomes 0. A times 1 minus 2 plus b times 0 equals to 1. This is a times minus 1 plus 0 equals to 1. So minus a equals to 0. So we have, sorry, 1 minute. Let me write the value. So a minus a equals to 1. So a equals to negative 1. So now the b value we need to find out. So that means we need to suppress here x minus 2 is 0. So x is equal to 2. What shall we do? Generally we put x is equal to 2 so as to get b value. So when you put x is equal to 2, you get x minus 2 will become 0. So a into 0 plus b times 2 minus 1 equals to 1. So 0 plus b into 1 equals to 1. This is 0 plus b equals to 1. As we know the a and b values, the partial fractions will be obtained. Okay, definitely Totakura Kishore, it will be kept. Therefore, 1 upon x minus 1 into x minus 2 equals to b is 1 upon b is positive 1 upon x minus 2, a is negative, so minus 1 upon x minus 1. These are the required partial fractions. So all of you just check the third problem. Once again rewrite the problem. So now the fifth problem. Resolve 1 upon x times x plus 1 into partial fractions. So let us solve this problem now. So can you solve this problem? What are the partial fractions of 1 upon x times x plus 1? Just you think. What do you get it? Right. So now the solution. Consider. So this comes under type 1 only because x is a linear factor, actually non-repeated, x plus 1 also non-repeated. 1 upon x times x plus 1 equals to a upon x plus b upon x plus 1. Am I correct this step? Check this step. Okay. Next, that implies we get like this. 1 upon x times x plus 1 equal to, here LCM is x times x plus 1. So x cancel, a times x plus 1 plus b times x. So this x into x plus 1, x into x plus 1 cancel. We have a times x plus 1 plus bx equals to 1 on comparing. So we get a times x plus 1 plus bx equals to 1. Now directly we can proceed to get a, put x is equal to 0. If you put x is equal to 0, what do you get? What do you get? Here a times 0 plus 1 plus b times 0 equal to 1. So 0 plus 1, 1. So a plus 0 equals to 1. So we get a equals to 1. The value of a has been obtained. So now we need to suppress this x plus 1. That means x plus 1 is equated to 0. So that we get x is equal to negative 1. So put x is equal to negative 1. If you put negative 1, this x plus 1 becomes 0. A times 0 plus b times negative 1 equals to 1. This is 0, negative b equals to 1. Negative b equals to 1. That implies b equals to negative 1. So as we know both the values a and b, so that we can substituting here, we get the required partial fractions. Good morning PSN. Good morning. So therefore, so 1 upon x times x plus 1 partial fractions. We are going to write now. A is 1 upon x, b is negative 1, minus 1 upon x plus 1. These are the partial fractions. I hope you might have understood this one. Right? So let us move to the sixth one. Shall we move to the sixth one? Yes, why not? Let us move to the sixth problem. Sixth problem. Okay. Sixth problem. All of you look at the screen. Resolve, that is sixth problem is 2x plus 3 upon x minus 1 into x minus 2 into partial fractions. Right? So now the solution follows like this. Consider 2x plus 3 upon x minus 1 times x minus 2 equals to, for x minus 1 there exists a partial fraction of the form a upon x minus 1, plus for x minus 2 there exists a partial fraction b upon x minus 2. So that implies we can have 2x plus 3 upon x minus 1 times x minus 2 equals to, here LCM is x minus 1 times x minus 2. X minus 1 gets cancelled, a times x minus 2 plus b times x minus 1. Okay, here now what happens now, these two will be gets cancelled, x minus 1 x minus 2 x minus 1 x minus 2. So now we can have a times x minus 2 plus b times x minus 1 equals to 2x plus 3. So now what shall we do now here? Yes, we need to suppress x minus 1 factor. How could you suppress it? It can be suppressed by equating x minus 1 equals to 0, so that we get x is equal to 1. That means put x is equal to 1. Then see what shall we get it? Yes, we get a times 1 minus 2, just substituting, plus b times, instead of x minus 1 0, so this is equal to 2 times 1 plus 3. This is a times negative 1 plus 0 equal to 2 plus 3. This is negative a equals to 5. So a equals to negative 5. A equals to negative 5. So now we need to just find out the b value, so that x minus 2 is equated to 0. X minus 2 equated to 0. X is equal to 2. So put x is equal to 2. So if you substitute x is equal to 2, this x minus 2 becomes 0, a times 0 plus b times 2 minus 1 equals to 2 times 2 minus 3. This becomes 0 plus b into 1, 4 minus 3. This is 0 plus b equals to 1. Now we know both a and b values. B is positive, a is negative. So 1 upon x minus 2 minus 5 upon x minus 1, we can write it. So that's why we can write here also. Hence, or therefore also we can write, hence the partial fractions of 2x plus 3 upon x minus 1 times x minus 2 are like this, we can write. So since a is negative, b is positive, first b write down 1 upon x minus 2, and next a with the negative value, here see you check minus 5, so minus 5 upon x minus 1. So these are the partial fractions. So we have resolved into the partial fractions. So one more question, let us discuss 7th question now. 7th question. 7th question. 1 upon x minus 1 times x minus 3. Resolve into the partial fractions. So just you need to practice all these questions so that you can solve any problem in any examination, whether it may be mid-term examination or final examination also. Solution. Consider 1 upon x minus 1 times x minus 3 equals to a upon x minus 1 plus b upon x minus 3. The same procedure. The Ganesh, welcome to the classes. So this we can write 1 upon x minus 1 times x minus 3 equals to x minus 1 times x minus 3 x minus 1 times x minus 3 divided by x minus 1, x minus 1, x minus 1 cancel, a times x minus 3 plus x minus 3 cancel, we have b times of x minus 1. So on comparing on both sides, x minus 1 times x minus 3, x minus 1, x minus 3, both are cancelled. Okay. So we get now a times of x minus 3 plus b times of x minus 1 equals to 1. Now we need to suppress this x minus 1. How could you suppress? You know the method. That is, x minus 1 is being equated to 0, so that we get x is equal to 1. Am I correct now? So that means x minus 1 is equated to 0. So we have x equals to 1. So that means put x is equal to 1. If you put x is equal to 1, this becomes 0. Whereas this one, a times 1 minus 3 plus b times 0 equals to 1 we have. That is a times negative 2 plus 0 equals to 1. So we have, this is minus 2a plus 0 minus 2a equals to 1. A equals to 1 upon minus 2, that is minus 1 upon 2. Minus 1 upon 2. So now we need to suppress the next factor x minus 3. So x minus 3 is equated to 0. We get x is equal to 3. Now put x is equal to 3. Then what do you get now here? Having been suppressed the x minus 3 factor, we are going to find out the b value here. So a multiplied by 0 plus b times 3 minus 1, 3 minus 1, 3 minus 1 equals to 1. So this is 0 plus 2b equals to 1. So 2b equals to 1. That implies what is the value of b? Yes, b equals to 1 upon 2. Am I correct? So you can check the calculations also. So the b is positive and a is negative. First b write down, next a write down. Partial fractions. So hence, sir, keep the two parts in description, please. Alright, keep the two parts in description. Okay. Hence 1 upon x minus 1 times x minus 3 equals to 1 by 2 upon x minus 3. A is negative, plus minus 1 upon 2 x minus 1. This can be rewritten as 1 upon 2 times of x minus 3 minus 1 upon 2 times of x minus 1. So these are the required partial fractions. So very good morning, Gayatri Sagar. Very good morning. So now let us move to the type 2, the new method. Type 2. This is very important. Please note down, this is type 2. This is very important question. Type 2. Type 2. That means when the denominator g of x contains repeated linear factors, so that is ax plus b all to the power of n. Suppose the ax plus b is the linear factor, is repeated for n times. This is called linear factor, repeated linear factor, ax plus b to the power of n, and also it may contain non-repeated also, and non-repeated linear factor, linear factor. that is of the form px plus q. So that means actually for every repeated linear factor ax plus b whole to the power of n, there exist partial fractions of the form from, we need to starting with ax plus b whole square, ax plus b whole cube, and so on up to ax plus b whole to the power of n. We get actually here n partial fractions. We will get it if it is repeated for n times. That will be in the form of like this. Say a1 upon ax plus b we need to write, plus a2, the second partial fraction, ax plus b whole square we need to write, and plus a3 upon, you might have expected, ax plus b whole cube, and plus so on like that, an upon ax plus b whole to the power of n. Here where a1 comma a2 comma a3 comma so on an are constants, they need to be evaluated. If you are able to find out this constant, that's all. The partial fractions of the type 2 also we can find out. Type 1 is g of x contains only non-repeated linear factors, but in the type 2, repeated linear factors as well as the non-repeated linear factors, that comes under type 2. So now if we discuss the examples, we shall get a good idea. So how to find out the partial fractions using type 2. So how could you recognize that? That comes under type 2 also. So let's have a discussion. If you do at least 4 or 5 problems, then definitely you can solve any sort of the problem which is related to the type 2. So let us proceed for the problem. So for how many problems we have completed? That is problem number 1 minute. Let me check the problems now. Right. 1 minute. Okay, 8 problems we have completed, right. Okay, this is also ninth problem. Ninth, okay. Resolve in ninth one, first problem. Resolve 1 upon x square into x plus 2 into partial fractions. This is the question. Partial fractions. Please note down all of you in your respective notes. I think you are ready with the notes. Okay, first this question. What is the difference between the type 1 and type 2 means? You check here. In the type 1 we have x only, but x square. That means x is repeated for 2 times. As x is repeated for 2 times, we get the 2 partial fractions. For x plus 2 we get 1 more partial fraction. Total 3 partial fractions we shall get it. So those 3 partial fractions need to be evaluated. We need to find out. Okay, let us directly proceed for the problem now. Solution. Consider this problem is type 2, that we need to first of all recognize. Right. Consider 1 upon x square times x plus 2. So for x square we get 2 partial fractions. For x first we need to write, say a upon x plus b upon x square, 2 partial fractions. But one more non-repeated linear factor is there. For that one there exists another partial fraction of the form c upon x plus 2. Now we need to find out a comma b comma c values. Okay, simplification. This is 1 upon x square times x plus 2. Here LCM will be obviously same only, write down x square times x plus 2. Now x square times x plus 2 divided by x. Here x times x plus 2 into a multiplied by x times x plus 2 plus x square gets cancelled, b times x plus 2 plus x plus 2 cancel, c times x square. So now these two are gets cancelled both sides. So we have, so live playlist is not there, Nana. You check offline classes only for second year. So now we can have a times x plus 2 plus b times x plus 2 plus c times of x square equals to 1. So first you remember one thing, Nana, here. So just if you want to find out here by substitution, if you put x is equal to 0, we can find out a b value. First let us substitute x is equal to 0. Put x is equal to 0. That means we are suppressing this x value factor. 0 into something 0 we can write, plus b of 0 plus 2 plus c times 0 equals to 1. That means 2b equals to 1. We have b equals to 1 upon 2. So one of the values have been determined. So now we can suppress this x plus 2 factor. Suppressing means x plus 2 is equated to 0. So x is equal to negative 2. Now put x is equal to negative 2. This x plus 2 becomes 0. This x plus 2 becomes 0. So 0 plus 0 equal to c, 1 minute, plus c times minus 2 square equals to 1 we have. This is c times 4 equals to 1. C equals to 1 upon 4. Both a value and c value known. But we need to find out now the a value. That is very, very important. So that means we need to simplify this one. You need to simplify this one now. We need to simplify. So that means again we have, you check, this is important step. This we can write ax into x, ax square, ax into 2ax, okay, bx plus 2b plus cx square equals to 1. So now what shall we do now? Ax square and cx square. Take x square common. So we get like this. A plus b times x square. Sorry, a plus c times x square. From these two x common. 2a plus b of x plus 2b equals to 1. Now both sides we need to compare the coefficient of x square. Right hand side we don't have any coefficient of x square. That means this a plus c must be 0. So that means comparing coefficient of x square on both sides. So comparing what happens now here? Here we have x square coefficient is a plus c. In right hand side only 1 we have. That's why we get, that implies a plus c equals to 0. We need a value. A is equal to negative c. Go back. What is the c value? Already determined. C value is 1 upon 4. So since c equals to 1 upon 4, a becomes negative c. that is minus 1 upon 4. A equals to minus 1 upon 4. Now partial fractions we can write. Thank you, Kishore. So now therefore, one upon x square times x plus 2 equals to, we have a upon x, so minus 1 upon 4 times x plus b, go back, what is the b? B is 1 upon 2, so 1 upon 2 upon x square, c is 1 upon 4 plus 1 upon 4 non-repeating linear factor, that is x plus 2. So it can be simplified. This is a negative, you can write last also. So this we can write 1 upon 4 times x plus 2 plus 1 upon 2x square and minus 1 upon 4x. So these are the partial fractions. So my dear children, please remember that this is type 2 is, you need to discuss very clearly. You need to solve more problems, because in the examination also you may be getting this type of question. So under 9th, let us move to the second bit now. Second bit. Resolve. Question will be like this in the examination only. 2x upon x square plus 2x plus 1 into partial fractions. Into partial fractions. Partial fractions. Okay. Solution. Consider this 2x x square plus 2x plus 1. Just observe this f of x, g of x. Denominator is a quadratic expression. So this x square plus 2x plus 1, rather in the form of a square plus 2ab plus b square, this can be written x plus 1 whole square. That means this is a repeated, it is in the form of repeated linear factor. So that's why we can write this equals to 2x upon x plus 1 whole square. So only we have repeated linear factor, but we don't have non-repeated linear factor. So that we can adopt one easy method is there, that I will explain. So whenever you come across only repeated linear factor is there, just you follow this method. So let us say, or better you say substitution only. So put x plus 1 equals to t. Now x becomes t minus 1. Now this 2x upon x plus 1 whole square becomes, instead of x substitute t minus 1, 2 times t minus 1 upon x plus 1 is t, so t square. So just you simplify it, open the bracket, 2t minus 2 upon t square. Now split it. This can be written 2t upon t square minus 2 upon t square. T by t square is t. So 2 upon t minus 2 upon t square. But what is t? T is nothing but x plus 1. So this equals to 2 upon x plus 1 minus 2 upon x plus 1 whole square. These are the partial fractions. Very simple manner we can find out this question. So this was given October 2011 examination question only. Third problem. Resolve 9 upon x minus 1 times x plus 2 whole square into partial fractions. First of all, read the question carefully. This is one of the important strategy need to be followed. This question was given in the examination October 2018. October 2018. I think this is very important problem. Very important problem. Compulsory you need to practice this question. Thank you. Thank you, Sandeep Reddy. Now the solution. So consider nine upon x minus 1 times x plus 2 whole square. See, x minus 1 is a non-repeated linear factor. What about x plus 2 whole square? This is a repeated linear factor. That means for x minus 1 there exists one partial fraction. For x plus 2 whole square there exist two partial fractions. Total we have 3. 3 need to be evaluated. For non-repeated linear factor x minus 1, we get a upon x minus 1 plus for x plus 2 whole square we get two more partial fractions, that is b upon x plus 1. First write down x plus 1. Next for x plus 2 whole square c upon x plus 2 whole square. This is the first step. The next step we need to follow like this. 9 upon x minus 1 times x plus 2 whole square. Here if you take the LCM, same thing we shall get it, that is x minus 1 times x plus 2 whole square. So x minus 1 into x plus 2 whole square divided by x minus 1, you get a times x plus 2 whole square plus x plus 1, sorry, this is x plus 2 whole square by x plus 2 here, b times x minus 1 into x plus 2 x plus 2 whole square cancel, c times x minus 1. See, and comparing this x minus 1 into x plus 2 whole square, x minus 1 into x plus 2 whole square cancel. So now this numerator equal to 9 we need to write. So we have a times x plus 2 whole square. So b times x minus 1 into x plus 2 plus c times x minus 1 equals to 9 we have. Right. So now here first put x minus 1 0, next x plus 2 0. So let us do it. If you equate x minus 1 is equal to 0, we get x equals to 1. So randomly also we can do like this. Put x is equal to 1. Now what do we get? Let us see. A times 1 plus 2 whole square. This x minus 1 becomes 0. This x minus 1 becomes 0. So plus 0 equal to 9. 2 plus 1 3. 3 square is 9. So 9a equals to 9. Obviously a becomes 9 upon 9 whose value is 1. So therefore a equals to 1 we have. Right. So let us take this part up too. Let us copy. This portion is very important for us. Right. Okay. Now x minus 1 is equated to 0. This time x plus 2 is equated to 0. Equate x plus 2 equals to 0. X plus 2 is equal to 0 means x is equal to negative 2. So now put x is equal to negative 2. So in this one, Now what do you get now? X plus 2 becomes 0. 0 plus 0 plus c times minus 2 minus 2 minus 1 equals to 9. This is minus 3c equals to 9. C equals to 9 upon minus 3. So 3 1 ja 3 3 ja minus 3. C value equals to minus 3. But we know both the values. What are the values so far we have evaluated? A value and C value. But we need to find out B value. So that means we need to simplify this one. How could we simplify? Just see this, open the bracket, we get like this: ax plus 2a plus bx minus b. Sorry, 1 minute, let me do like this. So we have ax plus 2a plus b times x minus 1 into x minus 2, that is x square plus x minus 2 plus cx minus c equals to 9. So now further we can simplify: ax plus 2a plus bx square plus bx minus 2b plus cx minus c equals to 9. 9. So very good morning. Right. So now this can be written like this: bx square, okay, right, bx square ax and bx plus a plus b of x, right, 2a minus 2b minus 2c plus 2a minus 2b minus c equals to 9. So comparing this constant to constant on both sides, comparing constant constant. 1 minute, we did wrong actually, I think so. Yes, a times x plus 2 whole square, that we have forgotten. A times x plus 2 whole square. Yes. Okay. Here x plus 2 whole square. Right. Now we have a times x plus 2 whole square means x square plus 4x plus 4 plus b times x minus 1 into x plus 2 is x square plus x minus 2. You can check it. This is cx minus c equals to 9. Right. So next, open the bracket: ax square plus 4ax plus 4a plus bx square plus bx minus 2b plus cx minus c equals to 9. Left hand side we need to simplify. See, ax square and bx square. Take x square common. We get a plus b times x square. Next, see, 4ax, bx, cx. Take x common. We get like this: 4a plus b plus c times x. Next, constant terms: 4a minus 2b minus 2c plus 4a minus 2b minus c equals to 9. See, in the right hand side, except constant there is no. So here other constants, there is no x square coefficient. So comparing x square coefficient. Comparing coefficient of x square on both sides. So we get this value. A plus b becomes 0. Okay. So go back. What is the a value? 1. We need b value. Understood now? So b equals to negative a. Since a equals to minus 1, obviously b becomes minus 1. So now we know a value is 1. Sorry, a value is 1. So this is b value is negative 1, c value is 3. So now the partial fractions we can write. So what are the partial fractions? Hence, so 9 upon x minus 1 into x plus 2 whole square equals to a upon x minus 1 plus b upon x plus 2 plus c upon x plus 2 whole square. We need to substitute respective a, b, c values. So let us check. What is the a value? A value is 1, b value is negative 1, c value is negative 3. Okay. So that means 1 upon x minus 1 minus 1 upon x plus 2. So minus 3 upon x plus 2 whole square. So these are the partial fractions. So in this way, we can find out the partial fractions. Okay, thank you. Bye bye. So tomorrow we shall continue and we shall discuss more problems because this type is very important. Santosh. Okay, tomorrow we shall see you. Thank you. Bye bye.